The factor theorem ties in with what we talked about yesterday in class. You'll have to forgive me, I'm losing my voice again, so I'll try and talk up. But yesterday in class we talked about how when you plug a number into a polynomial, the y value you get out tells you how far away from being a solution it is. So if I plugged a number into a polynomial and the y value that I get out is 0, then that's telling me that it's an x-intercept on my graph. So I just found the y-coordinate was 0, which means it hits the x-axis. So if it's an x-intercept, then another word for that is a root or a solution. So if x equals a is a root, then x minus a is a factor. And that's what the factor theorem is saying. So what we talked about yesterday with the remainder theorem was that if you plug in a and you get some other number, then that's essentially telling you how far from being on the y-axis or the x-axis it is. It's telling you how far from being a solution are you. So if you got, on one of the problems we did, our remainder was just 2. So what that told us was that while our x value wasn't an actual solution, it was pretty close to a solution because the y value was really close to 0. And so that's what the remainder theorem told us yesterday. And so that also means if the y value is 0, then you've just found a solution to your equation and you've just found a factor of your equation. So what we do is, if I want to know if x equals 2 is a solution, then I'm going to use some synthetic division to determine that. And you need to pay really careful attention. I'm going to put a great big star there, because when we've done all of our previous work with our synthetic division and even with our long division, this was always written as x minus 2. We were always dividing by a linear equation. And so when we set up our synthetic division yesterday, we had to do a sign change. You've got to pay attention because this is not written as x minus 2. This has already been solved. This is already x equals 2. So there's no sign change attached when we put it in the box for the synthetic division. So you've got to make sure that you pay attention to that. So we are dividing by x minus 2. So we put 2 into the synthetic division box, and we're going to see if our remainder is 0. We're going to see if it divides out perfectly. So we're dividing it out of 2x to the 4th, 5x cubed, minus 8x squared, minus 17x minus 6. Okay, so carry my 2 down. And remember the 2-cycle pattern. So we multiply diagonally. So 2 times 2 gave me 4, and then I add down, which gives me 9. And I know it's a little repetitive. I'm more going through the steps for those people who were absent yesterday. 2 times 9 is 18. And then we add down and we get 10. 2 times 10 is 20. Add down and you get 3. And 2 times 3 is 6, and you add down. And remember that that last number right there is your remainder. So what that just told me was, yes, x equals 2 is a root. X minus 2 is a factor of my equation. It divided out perfectly. And ultimately what our goal would be to take the remaining equation and continue factoring it down and solving it. Right now, you guys wouldn't have the ability to do this cubic that's left, not until we get into the rational root theorem next week. Okay, so then I want you guys to take a second, and I'm just going to stay quiet because I don't want the sub to have to deal with pausing and unpausing. Take a second and see if -3 is a solution to the Corsican number 2. Okay, so whenever you're ready, you can look up, and hopefully this is what you got for your remainder. Right around here or so, you can usually tell that the numbers are not multiplying and adding to anywhere near what they need to become 0 ultimately. So normally we would have stopped right around there. We would not have needed to finish the entire problem just to determine that x equals -3 is not a root, which tells us x plus 3 is not a factor. Okay, so one way to use the synthetic division from yesterday is to determine whether something is a solution or a factor. The other way is to actually solve, or to actually factor an equation and solve it. So before I do the first example for you guys, I want to remind you that, let's say I gave you a relatively funny number to factor. If I said, okay, I want you to factor that number, 748. Let's say you guys decide to pull 2 out first. Okay, so you pull a 2 out of that number and you reduce it down to 374. When you decide you're going to pull 2 out again, or even if you decide you're going to pull out a different number, whatever number you decide you're going to pull out next, do you go all the way back up to the 748 to pull that number out? Hopefully you just thought no to yourself. So any other numbers you decide to pull out, you would pull out from the reduced number. The same thing goes for polynomials. When you have a cubic right here, when I pull this root out of it, it will reduce that cubic down to a quadratic. Any other solutions I find, I'm going to do it from that quadratic. I'm not going to come back up to that cubic ever. Okay, so once you find one solution for that cubic, you are done using that whole cubic for the problem. You're going to do everything else with the reduced equation. So I'm going to pull -2 out of my cubic. So 6x cubed, 11x squared, minus 4x minus 4. Carry the 6 down. Multiply and get -12, and add down and get -1. Multiply and get 2, and add down and get -2, and multiply and get 4. And sure enough, there's my remainder of 0. So, not only have we proved that this is a root, we have proved that x plus 2 is a factor of the equation, and we have successfully pulled that factor out. It's just like this 2 sitting out here now. It's pulled out. We've reduced our equation down. So x plus 2 has been pulled out of our cubic, and what we are left with down here at the bottom is 6x squared minus x minus 2. So the rest of my solving is going to be done with that quadratic. I'm not going to go back up to the cubic ever. So I take that quadratic, and it is factorable, but if you can't figure out how to factor it, or if you are accident prone with your swing method, or you're not very good at your grouping, then you could do the quadratic formula. But it does factor. It factors as 2x plus 1 and 3x minus 2. And so that means that x equals -1/2 or x equals positive 2/3 are the other two roots. So there's the answer to the question, because the question said, what are the remaining roots? Okay, on your test on Monday and Tuesday, that week before spring break, the problems are going to have a blank, 2 blanks at the bottom, where I'm going to ask you for a list of factors and a list of roots, a complete list of factors and roots. So you would say this: here's all 3 of your factors for that cubic, and there's all 3 of your roots for that cubic. Okay? So once again, I'm going to pause. I want you guys to get this one started. Okay, we already know our remainder is going to be 0, so I want you to divide that root out. Remember, that means you're dividing by x minus 4, proving it's a factor. And then we'll finish the rest together. Okay, let's see how you guys did. So we multiply and add down. We multiply and add down. We multiply and add down. And last but not least. So there's our remainder of 0. Okay, so we have divided x minus 4 out of our quartic equation, and this is what we're left with. And what that is 4x cubed minus 4x squared minus 9x plus 9. Okay, so that we're left with the cubic, which earlier on I said that you didn't have the ability to solve that cubic yet. Well, this cubic is different, because this cubic you can factor with a method you know. So hopefully you're thinking or saying out loud that this cubic could be factored by grouping. So I'm going to group the first two, group the last two. The greatest common factor for the first two is 4x squared, and it leaves x minus 1. And then for the last two we have minus 9, which also leaves x minus 1. So I pull out the x minus 1, and it leaves 4x squared minus 9. Okay, I'm not done factoring yet. I'm just going to slide off to the side because I'm running out of room. So keep in mind, we've already pulled out the x minus 4. Now we've got the x minus 1 out. This quadratic, though, is a difference of 2 squares. I wouldn't have to factor it to solve it, but if I want my complete list of factors, like on your test in a little over a week, I would split it up. It factors as 2x plus 3 and 2x minus 3. And so I already knew this root. I already knew x was equal to 4. The other roots that I get x equals 1, and I get x equals plus or minus 3/2. So there's my remaining roots. Okay. So hopefully this is all coming back to you guys. I'm sorry I can't be with you. As sniffly and raspy as I sound, I'm actually out because my older son needs me today. So I hope you guys are feeling good about the unit so far. Like I said, I know we're moving quickly, but that's because most of this unit you guys have already done before. So message me or email me if you have questions. Otherwise, I will definitely be back on Monday, and we'll do the rational root theorem and some question and answer time. Have a good weekend, y'all.